Question 2d, Part 1. Find the integral of cos 3x dx. One way to help recall how to differentiate or integrate the trigonometric functions y equals sin x or y equals cos x is the trigonometric circle. It looks something like this. We start off by writing sin x at the top of the circle, and then going clockwise, we write cos x, and then negative sin x, and then negative cos x. Then it returns back to sin x here. Now going forwards or clockwise is differentiating, and going anti-clockwise or in reverse is integrating. So starting off with sin x, differentiating sin x, we get cos x. Differentiate cos x, we get negative sin x. Differentiate negative sin x, we get negative cos x. Differentiate negative cos x, we return back to sin x. In this question though, it's asking for the integral of the cosine function, in particular cos of ax. So referring back to the trigonometric circle, the integral of cos x is sin x. So we know that the primitive must involve the sine function. Now the integral of cos ax dx, where a is a constant, is equal to sine of ax divided by the derivative of what's inside the brackets. So the derivative of ax is just a. So the integral of cos ax dx is equal to sine ax, in brackets, divided by a plus the constant of integration c. And it can be written as 1 over a times sine of ax plus the constant of integration c. Now in this case, a is equal to 3. Hence, the integral of cos 3x dx is equal to 1 over 3 times sine of 3x plus the constant of integration c. Part 2. Find the definite integral from x equals 0 to x equals 1 of e to the power of 5x minus 1 dx. Recall that the integral or the antiderivative of e to the power of ax dx, where a is a non-zero constant, is equal to 1 over a times e to the power of ax plus the constant of integration c. Now the question is asking for the definite integral of e to the power of 5x minus 1. And because it's a definite integral, the answer will not contain a constant of integration. So applying this rule to the exponential function e to the power of 5x, the integral from x equals 0 to x equals 1 of e to the power of 5x minus 1 dx is equal to 1 over 5 times e to the power of 5x minus x from x equals 0 to x equals 1. Applying the limits of integration, that equals 1 over 5 times e to the power of 5 minus 1 in brackets minus 1 over 5 times e to the power of 0 minus 1. Recall that e to the power of 0 will equal 1. And that equals 1 over 5 times e to the power of 5 minus 1 minus 1 over 5. And that equals 1 over 5 times e to the power of 5 minus 6 over 5, or factorising out 1 over 5 from both of these terms, we get 1 over 5 outside of e to the power of 5 minus 6.